My name is Louise Huang, and I direct the Center for Research in Science. I am delighted to share with you today something that's near and dear to my heart. Did you know that based on the distance between the Earth and the Sun, the average temperature on Earth should be minus 18 degrees centigrade or 0 degree Fahrenheit? That is very cold, isn't it? I'm sure you've noticed that that is not the case. The actual temperature on Earth really is 15 degrees centigrade or 59 degrees Fahrenheit. So why is there a difference, a big difference between 0 degrees to 59 degrees Fahrenheit? That is because something is at play. And I believe that is also the Creator God's infinite wisdom and deep love and grace for us to create and design a non-freezing condition so that we can live on this planet comfortably, so that it will allow us to thrive and flourish. That condition at play is the greenhouse effect. Let's take a look at the energy of the Earth. The sun supplies a tremendous amount of infrared, visible light, and ultraviolet energy to the Earth. And the atmospheric gases actually can trap major portion of the infrared energy, and as a result, warming the Earth. This is the greenhouse effect. It is natural and necessary. There's about 80% of these energy, infrared energy, that is being trapped by the atmospheric gases. Now, you can imagine a parked car with windows closed in the middle of a parking lot on a hot day. That is equivalent to what the greenhouse effect is, warming the atmosphere by these gases such as water vapor, carbon dioxide, methane, so on and so forth. However, even when we have too good of a good thing, may not be very beneficial. When there is more than 80% of these atmospheric gases trapping the infrared energy, we will see an additional warming. And global warming, therefore, is an increase in average global temperature resulting from an enhanced greenhouse effect. Now, indeed, Earth's climate is affected by natural phenomena, such as the orbit and the tilt of the axis, and the change in concentration of carbon dioxide and other atmospheric gases. However, the Earth's climate has been affected by human-caused influences such as industry, transportation, mining, and agriculture, bringing upon an unnatural influx of carbon dioxide. This next pie chart, you could see that the different carbon dioxide emission sources by end use, and you can see here that we are all part of this and no one's left behind. So, how much carbon dioxide are we really talking about? Well, let's take a look at this set of study taking place in Mauna Loa from 1958 to 2010. On this graph, you will see that year is on the x-axis and concentration of carbon dioxide in parts per million is on the y-axis. The red zigzag line shows the measurement of carbon dioxide concentration over time. The black solid line is a trend line. You see in the inlet window that there is a carbon dioxide cycle through the calendar year. So you can see here that the amount of carbon dioxide concentration over time steadily increases, indicating that there is a trend, an increasing trend. Now I wonder if some of you are thinking, well, that's good for 1958 to 2010. What about before 1958? Well, actually, teams of scientists went to the coldest part on our Earth and went to the ice caves in Antarctica to measure and analyze the amount of carbon dioxide concentration. It was frozen to compare to the data that you just saw. And these are the results. Again, time is on the x-axis and carbon dioxide concentration in parts per million is on the y-axis. So you can see here that from the year 1000 to 1800, the amount of carbon dioxide concentration is quite steady. And then there is an increase starting at 1800, and then seemingly a climb that is continuous after that. The question then is, what happened in 1800? The Industrial Revolution ushered it into a new era of modern conveniences and technologies, such as driving automobiles, using fossil fuels. That has become part of our everyday life. However, that might have been also bringing upon some unintended consequences. And that is quite common in science. Many turn to science for answers and solutions without realizing that there are actually many questions that can be raised in the process. So let's take a look at carbon dioxide concentration. Did you know that as early as the 18th century, French scientist Fourier already suspected that there is a relationship between carbon dioxide and temperature? Following him, Tyndall, Arrhenius, Callendar, they all studied the relationship between carbon dioxide and temperature, finding out that there is increase when one increases. Here is the average global surface temperature over a period of time. Again, time is on the x-axis from 1880 all the way to present time. And then the average temperature in degrees Celsius relative to 1901 to 2000. The zero line, black line in the middle, you can see is the average. So whenever we see a red bar that is below the black line, that means that the average temperature that year is below average or colder than usual. And whenever we see the black line having the red bar above it, that means that year we have the temperature that is above average or hotter than usual. The blue line is a trend line, and the black arrow bars just shows a range of those temperatures. Now we can see here that before 1940, we have quite a number of below average temperatures. But after 1940, we see less of that, and after 1980, we see even less of that. And if that is true, what Fourier, Tyndall, Arrhenius, and Callendar all studied and proposed, then we should see some kind of a correspondence and relationship between the increase of carbon dioxide concentration and global temperature. So, putting the two together, you see here again, year on the x-axis, the concentration of carbon dioxide on the left y-axis and temperature on the right y-axis. You can see the blue line is carbon dioxide concentration and the red line is temperature. That we can see a close resemblance. As carbon dioxide concentration increases, the global average temperature also increases. So, is global warming or the warming of the Earth's temperature the only consequence? Turns out that there are more consequences than just warming the global temperature. According to the National Climate Assessment Report in 2018, there are multiple areas and consequences. Our climate is changing, and our temperature has increased by more than 1.2 degrees Fahrenheit for the period 1986 to 2016. That means in these last 30 years, relative to the beginning of the century, it is now recorded as the warmest part in history of the modern civilization. But that's not it. Warming global temperature also affect polar cap ice and glaciers. Shown here on top, you can see is the NASA study, the Arctic ice area in 1984, and just about 30 years later, the size of the Arctic ice in 2016. Not just in the Arctic, but also in Athabasca Glacier in Alberta, Canada. We're seeing that the glacier was at the point where you see the sign 1992, but in 20 years, the glacier receded to the back of the photo. You might think that these are all places very far away from us and we are not affected. Well, it turns out that the melting of snowpack and glacier affect our water resources. And this will lead to chronic drought and extended periods. Speaking of the ocean, so it turns out the loss of polar cap ice will also affect the rising of sea levels, especially affecting the low-lying areas and coastal regions, such as the Kiribati Islands. The Kiribati Islands are in the middle of the Pacific Ocean, and because of sea level rise, this is the reality of their residents. global average sea level has risen about 7 to 8 inches since 1900, with almost half of that rise occurring since 1993. Not just that, global average sea levels are expected to continue to rise another several inches in the next 15 years or so, and as much as 1 to 4 feet by 2100. Now, speaking of the ocean, because of this increased amount of carbon dioxide concentration, it doesn't just dissolve or rest on land, but it also would dissolve in the ocean, affecting the intricate pH level, which is how acidic or basic the ocean is to support its marine ecosystem. So with the additional carbon dioxide concentration dissolving into the ocean, it will lead to acidification, which can affect greatly the coral system and shellfish, not just in the ocean, but also on land. It is estimated that about 10 to 690 species will face extinction every week because of the changing climate. In addition, there's also the consequence of increased droughts, flooding, wildfires, and extreme storms. So, what do all these mean for us? Well, here in Southern California, we are very familiar with these headlines that don't seem to go away, and in fact, more exasperated as we go through the years. And this year, we're hearing that happening also in Australia. So we can expect even more of these disasters in the years to come. But not just that, it's costing us a lot of money. According to this research published on the journal Science, it is estimated that per 1 degree centigrade increase in global average temperature, it will cost us 1.2% GDP. And if our GDP in 2016 was 18.57 trillion US dollars, this will cost us 220 billion US dollars. Not just that, it also means that we will have a large ecological footprint. Shown here is the ecological footprint of the US, which is per hectare acre per person, needed to provide the resources to feed, clothe, transport, and shelter someone in that country. Well, let's take a look and compare the ecological footprint of another developed country, such as France. You see here that is at 4.2. What about Mexico, our neighbor, at 2.4, and China at 2.5? Global average, 2.7. Even though we might have big feet, I think by the same token, we can also effect change if we choose to do so, and if we bring upon significant influences. And turns out I'm not the only one who thinks that way. Pope Francis, when he made his historical visit to the US in 2015, spoke in the Congress based on his encyclical Laudato Si. He encouraged us to be a leader, to be an influence in these areas, particularly in the area of stewardship. Leading British evangelical leader, the late John Stott, wrote in his last book, his parting words to the church, warned us that there are 9 areas of calling that has been neglected, and right in the middle of it is creation care. And he said, it is against the background of this wholesome biblical teaching that we need now to confront the current ecological crisis. So, what can we do? Well, first, you can take a carbon footprint inventory by using the Environmental Protection Agency calculator that is shown here, and get an idea of how big are our footprints. And then you can make other choices of transportation and maybe replacing some of the non-energy saving items with energy saving items. Consider reducing consumption, because that is the most preferred way, as opposed to even recycling or incineration. Now, in a corporate level, carbon dioxide sequestration could be very effective when we build ducts right underneath a plant to kind of channel and capture extra carbon dioxide away from the source. There's also a very creative method called cap and trade system that can be used between different companies or factories, that they can work out some kind of an overall carbon dioxide concentration to monitor or reduce, minimize the amount instead of adhering to a mandatory reduction rate. All these will make a difference because shown here are two predictions of global temperature in the years to come, as well as the carbon dioxide concentration on the right. I'm highlighting to you the different pathways that can happen. We can choose to not do anything and go follow the very high pathway on top, or we could choose to do something to mitigate in between so that we will not end up there. The choice is ours. What we choose to do today will make an impact in the years to come. So why do I care about climate change? Because I believe this is our only home. And God created it. And if I am to love God with all my heart, soul, mind, and strength, I must take care of what He created and loves. Secondly, to me, God has called me to love my neighbors. And when I look at the consequences of climate change, and when I look at how the most vulnerable, the most marginalized might have been affected as a consequence of climate change, and I think about what action or inaction of mine that have brought upon their suffering, I started to wonder, should I do something different? I want to leave you with an image. It says on top, why sustainability is important to everyone. A group of people were traveling in a boat. One of them took a drill and began to drill a hole beneath himself. His companion said to him, "Why are you doing this?" replied the man. "What concern is it of yours? Am I not drilling under my own place?" They said to him, "But you will flood the boat for us all." Maybe we are more interconnected than we think we are. May we go forward in fulfilling the great commandments by honoring God, loving our neighbors, sustaining all of God's creation, and bringing shalom to all so that there is flourishing.